Let's take a look at the homework problems on page 452, and in this section we are finding the area between two curves. And just a quick review, remember when we are finding the area between two curves in terms of x, we are looking for a top curve and a bottom curve, and we're going to subtract. So in number 2 and 3, you're not going to evaluate these, you're simply setting them up, and they've already provided the graph for you. And we can see that the first point of intersection where we're going to start our accumulation is -2, and we're going to stop the accumulation at +2. When you look at the graph, you can see that the line, or the g of x function, is on top in this region of area, and that the parabola is the curve that is on the bottom. In other words, it is beneath the area that is encapsulated between the two curves. So in this case, we're going to start accumulating area in number 2 at an x value of -2. We're going to stop at +2. The top curve is g, in this case it's the line g of x minus the parabola f of x dx, and you do not have to evaluate this. In this problem, since they gave you the names of functions, it is okay to use the names, or you could have had this written as -2 to 2 of the g function, which is 2x plus 5. Put these functions in parentheses, particularly the second function, because you have to distribute. If we were going to evaluate, you'd have to distribute that negative through. So either one of these would be acceptable since you're setting up only. Number 3 is another setup only, and in number 3 you can see that the first point of intersection they provided for us is 0, and the second point of intersection that they've provided for us on that sketch is 3. So we're going to start the accumulation of the area at an x value of 0, stopping at an x value of 3. The curve that is on top in this particular region is the g curve, the downward opening parabola, and the curve that is on the bottom is the f curve, the upward opening parabola. So we have the top curve and we have the bottom curve. Remember, kind of like if you were standing inside, if that was a room and you were standing inside like this, if you look up you see the red curve, if you look down you see the black curve. So we're accumulating area. Remember, it's top minus bottom, so it's the g curve, top, minus, in this case, the f curve, bottom. And again, you could have written out the actual functions. Make sure that you put parentheses. So that would be set up for the area between two curves. All right, let's take a look at problem 17. And then number 17, you have to sketch your graph. Sketching these graphs is a little bit can be misleading if you don't sketch fairly accurately, so I will say that. And secondly, I will tell you on the AP test, usually, that's not 100% of the time, but in the high 90s, usually the graph is provided for you so that you don't mislead yourself and mess up the problem because of a bad sketch. Or it might be on the calculator part of a test where you could get an accurate graph. All right, so I'm going to sketch 1/2 x cubed plus 2, which is a cubic function shifted up 2 units, and it's dilated, so it's a little skinnier. So it might look something like that. That's my cubic function. And then I'm going to sketch the second function, which is x plus y, which is a line with a y-intercept of 1, rise 1, run 1, something like that. And the line would look something like that. Now notice here I have more boundaries. So I have the red boundary, the blue boundary. I also have x equal to 0. X equal to 0 is a vertical line. So this is my x equal to 0. So that's just closing off and saying this is one up the wall. So think of it like the red is the ceiling, the blue is the floor, and the orange is one of the walls. And then they're going to bound us also at x equal to 2. X equal to 2 is a vertical line, so there's 1, 2, and so the vertical line would bound me sort of like this. I'll make the red go up a little bit more. All right, so I have the red curve, which is the ceiling, The blue is the floor, orange is a wall, green is a wall. The region that we are encapsulating here, however, is this little region right in here. We're trying to find the area between the red curve and the blue curve. So hopefully you can see we're going to start the area accumulation at the orange, which is x equal to 0, and we're going to stop the area accumulation at x equal to 2. So to accumulate the area between the two curves, we're going to start at the x value of 0, stop at the x value of 2. The top curve is red. Now this time notice they're both called y, so I'm going to write my function 1/2 x cubed plus 2 minus parentheses. The parentheses are very important, dx. Now we have to evaluate this, so I'm going to do 0 to 2. I'm going to distribute and combine any like terms, so I have 1/2 x cubed minus x. Remember, I'm distributing the negative here, and I'm distributing the negative, so 2 minus 1 is plus 1 dx. Now I'm going to take it one more step. I'm not going to do the I'm not going to do the evaluation just for the interest of time. 0 to 2, so I'm going to increase the power by 1, so that gives me x to the 4th over 4, so that would be a 1/8 x to the 4th minus x squared over 2. I don't need that integral anymore, do I, if I'm going to integrate? Let's get rid of that. And then plus x evaluated from 0 to 2. Be thankful for the 0 because that's going to make everything go away. And when you evaluate that all the way through, just so you don't have to look this up in the solutions manual, the final evaluation answer will be positive 2. So that's what you should get if you do the arithmetic correctly. All right, let me clear my screen and let's take a look at number 19. In number 19, we have a parabola. It's opening upward. And we have g of x, or y equals 0. That's a horizontal line. That's actually the equation of the x-axis. All right, so let's make a little sketch here. And we're going to have to remember some things about finding the vertex of a parabola. So I'm going to take x squared minus 4x, which is my f of x. And I'm trying to find the vertex. I need the vertex to sketch the parabola, and you may or may not remember this, but the way you find the x-coordinate of the vertex is you take the opposite of b divided by 2a. It's that front part of the quadratic formula. So in this case, the opposite of b, my b value is -4, and the opposite of that is +4, over 2 times 1 is equal to 2. So the x-coordinate of my vertex of this parabola is 2. To get the y-coordinate, I'm going to substitute a 2 and substitute a 2. So that'll give me 4 minus 8, and 4 minus 8 is -4. So I have 1, 2, 1, 2, 3, 4. Right, so there's my vertex for number 19. Now I'm going to draw my upward opening parabola, but I'm not telling you that it's indicating for sure where the x-intercepts are, whoops, because I have not done that work yet. But I'm just drawing an upward opening parabola, so I cannot trust that sketch to determine my x-intercepts. And then I have the line, the x-axis, so this is the boundary on top. So I have a top curve and I have a bottom curve. Now what I need to figure out is these 2 points of intersection. So to do that, I'm going to do some algebra. So I'm going to take the parabola, which is x squared minus 4x. I'm going to set it equal to the line. I'm going to factor out an x, and that gives me x minus 4 equal to 0. So I get x equal to 0 and x equal to 4. So even though my graph doesn't portray it because it was a sketch, this is x equal to 0, this is x equal to 4. So I'm going to start my area between two curve accumulations, starting with the low bound of x equal to 0, stopping with the high bound of 4. The top curve is blue in that entire region. This is the top. This is the region that we're trying to find the area of, and remember, the area between two curves is always positive. This is not your typical net area of accumulation. We're doing top minus bottom. So the top curve is 0, and I'm going to write it for emphasis because that minus that we're getting ready to deal with is going to be really, really important, and that's what's going to make your, when you look at that graph, you're like, I think this answer is going to be negative because it's net accumulation, but look what we're doing right here. Top curve minus the bottom curve. This is why your answer is going to turn out being positive instead of the negative that you would anticipate. So top curve minus the bottom curve. I got to sneeze here, so I'm going to pause real quick. All right, so that's your bottom curve. And so we're at the accumulation. There's my dx. So cleaning that up gives me 0 to 4 of, distribute the negative to both terms. Find the antiderivative, negative x cubed plus 4x squared over 2, which is 2x squared. Oh, I love those zeros. All right, do the evaluation. And when you do the evaluation of this problem, you should get 32 over 3. So let's take a look now at number 21. And the number 21, I'm going to approach that problem without necessarily graphing it, and pretend like I'm not sure what the graph looks like, and I'm wondering if there's a way for me to figure this out without necessarily graphing. So if you think about the fact that we know that we have two curves, we have in number 21 a parabola that is opening upward, and we have a line that is increasing because it has a positive slope. So basically, I do know that I have an upward opening parabola. I'm not sketching it accurately at all, and a line that is increasing. So it's likely that I have something that looks like that. But I'm going to, again, pretend that I'm not exactly sure that that's what the region looks like. So I'm going to get rid of that graph, and to determine how to find the area between these two curves first, I'm going to find the points of intersection. So remember, to find the points of intersection, I'm going to set the two functions equal to each other and solve algebraically. So x squared plus 2x plus 1 equal to 3x plus 3. And since this is quadratic, I'm going to make that equal 0, and I'm going to subtract 3x from both sides and subtract 3 from both sides. And I'm going to factor. And I'm going to have a 2 and a 1 and a minus and a plus. And I have x equal to 2 as one of the points of intersection and x equal to -1. All right, so that helps me to begin setting up my integral. I know I'm accumulating area from -1 to 2. There are 2 points of intersection where the line and the parabola intersect. Now I'm curious, I think I have a pretty good idea that the line is on top the whole time, but I want to make sure that the line is on top or the parabola is on top. So I'm going to choose a number between -1 and 2. Between -1 and 2. And the number between -1 and 2, the easy number is 0. So I'm going to choose 0, and I'm going to substitute 0 into each of the two functions. So I'm going to substitute 0 into the parabola. So I have 0 squared plus 2 times 0 plus 1, which equals to 1. And then I'm going to substitute 0 into the line. So that gives me 3 times 0 plus 3, which is 3. So clearly 3 is greater than 1, so that means that the line is on top and the parabola is on the bottom. That's just a real easy way to figure out if you only have 2 points, or even if you have multiple points of intersection, you can check each region. So the top curve, quote-unquote curve, in this case is the line, 3x plus 3, minus the bottom curve, which is -x squared plus 4x. Oops, I'm starting to copy the wrong problem. Plus 2x plus 1 dx. I'm going to clean that up a little bit and make that -1 to 2 distribute. That makes positive x squared, distribute, that makes negative 2x and 3x, which is a plus x. Distribute, that makes negative 1 and 3, which is a plus 2 dx. And when I find the antiderivative, I'll get x cubed over 3 plus, whoops, eraser. Come on, eraser. There we go. Plus x squared over 2 plus 2x evaluated from negative 1 to 2. And when you do that evaluation, let me tell you what you will get so that you don't have to necessarily look it up in the solutions manual. By the way, I just caught another error. Again, I started looking at number 20. So this is a plus x squared. So x squared plus 2x plus 1. And that would be a minus x cubed over 3 and a minus. That was my fault because I started looking at problem number 20 instead of 21 when I was copying my two functions down. You probably already have picked up on that, so good for you. So 21, the final answer evaluated correctly is 9 over 2. Lastly, we're going to do problem number 25. Let me reset the screen. And 35 is a calculator problem. So this is an opportunity to practice using your calculator. And you can see I've copied the problem. I've double checked it because you know my mistakes on copying, starting to copy the wrong problem. We'll check it one more time. X squared minus 4x plus 3. That's good. 3 plus 4x minus x squared. Okay, so let me bring my calculator up. Calculator is going to do most of the work, and I'll show you what you have to actually write for credit. So since this is a calculator problem, I'm going to put in my first function, which is x squared minus 4x plus 3. All right, double check it, x squared minus 4x plus 3. And then my second function is 3 plus 4x minus x squared. 3 plus 4x minus x squared. When I'm graphing, I start with a zoom 6 window. That's a standard viewing window, just to, that's kind of like my home base. And that window is going to do perfectly fine. Now remember, this time I don't have to do any of the work. Calculator is going to do the work, but I do have to show the setup. The red parabola, the downward opening parabola, is on top, and the blue upward opening parabola is on the bottom. So I have to remember where those functions are. So the blue parabola is in y1, and the red parabola is in y number 2. All right, now let's go get those points of intersection, and the way we're going to do that is a second calc. We're looking for number 5, which is an intersection. Notice that my cursor is very close to where we believe the point of intersection to be, so we're going to do enter, enter, enter. Now that point of intersection is 0, and it does not need to be stored because it's just 0. I don't have this long decimal number that I need for the calculator to hold for me. And then, so I'm going to start my integral. So this is what we have to actually write on the paper. We have a low bound of 0. We haven't found the upper bound yet. We said the top curve is the downward opening parabola, so that's 3 plus 4x minus x squared. Top curve minus the bottom curve is the upward opening parabola, x squared minus 4x plus 3 dx. And that's really, we don't have to distribute or combine like terms because the calculator is going to do the work. Let's get that other point of intersection. So I'm going to do again a second calc. Intersect is number 5. Move the cursor closer to the second point of intersection. It does not have to be on top of it. Enter, enter, enter. And the point of intersection is x equal to 4. That does not need to be stored into my calculator because it's not a long string of decimals. Okay, now I'm going to let the calculator do its work. I'm going to go to a home screen. I'm going to do a second quit. Here we go. So I'm going to math 9. I'm going to find the integral of, starting with a low bound of 0, going to a high bound of 4. Now I can either type in the functions again, but I've already got them stored in my y1s and y2s. remember that, let me go back to my screen, the upward opening parabola is stored into y1. This is really important because you get the wrong answer. You would get a negative answer. And my downward opening parabola is stored in y2. So when I use the calculator, I'm going to call up, I'm going to use my shortcut buttons. So I'm going to press the green alpha and F3. And I want to select y number 2, because that's the top function, minus alpha F4, and y1 is the bottom function. In terms of x, enter, and we get 21 1/3. So when it has that 0.33, now on the AP test, you probably would be nervous about changing that to the third. So you can just write it as 21.333, but make sure you put 3 decimal places. So my answer is 21.333. So these are area between two curves, and all of these problems are in terms of x.